Hello everyone, welcome back to my channel. This is a video on blue-green deployment based interview questions part 2. So let's start. The first question is, how do you switch traffic between blue and green environment in a blue-green deployment? The answer is, in a blue-green deployment, the goal is to seamlessly switch traffic between two identical environments, blue and green, to ensure high availability, zero downtime, and safe deployments. The key steps to achieve this switch effectively are: first is preparation of the green environment. First, deploy the new version of the application to the green environment, which is identical to the current live blue environment. Ensure the green environment has passed all the testing, like unit testing, integration testing, performance testing, and UAT, to guarantee it's production ready. The second point is traffic routing. The switch itself relies on controlling the traffic routing mechanism. Typically, this is handled by the load balancer, DNS, or a cloud native service like AWS Elastic Load Balancer ELB, Azure Traffic Manager, or Kubernetes Ingress. For load balancer or reverse proxy, once the green environment is ready, the traffic can be routed from the blue to the green environment. This is achieved by updating the configuration of the load balancer to point to the green environment's resources instead of blue environment, depending on your infrastructure. For DNS switch, change the DNS records to point to the green environment's IP addresses. For load balancer updates, in cloud environments like AWS or GCP, change the target group for your load balancer to point to the green environment instances. For canary deployment, gradually route a percentage of traffic to green and monitor the performance before fully switching. The third point is health checks and monitoring. During the traffic switch, health checks play a crucial role in ensuring that the green environment is fully functional before it starts receiving the production traffic. If the green environment fails the health checks, traffic should be redirected back to the blue environment. Continuous monitoring is essential to ensure that everything works as expected once the traffic is switched. Tools like Prometheus, Grafana, Datadog, or ELK Stack can help track key metrics like response times, error rates, and throughput. The fourth point is complete traffic switch. After the health checks pass and the traffic has been gradually shifted, a full switch can be made. This means all the production traffic is now directed to the green environment and the blue environment is idle or marked for the next deployment. The fifth is rollback strategy. In case of issues with the green environment after the switch, rollback is straightforward. You simply route traffic back to the blue environment by reconfiguring the load balancer, the DNS, or proxy to point back to the blue environment. Since both the environments are identical, the blue environment is a reliable failover. The sixth point is post-deployment. Once green is fully handling the traffic, you can decommission the blue environment or use it for the next cycle, for example, for the next release or maintenance. The key benefits include zero downtime, that is, the transition from blue to green happens without any service disruption, ensuring a smooth experience for users. Second is easy rollback. If any issues occur, it's easy to roll back to the blue environment with minimal effort. Third is risk mitigation. The gradual shift in traffic allows for careful monitoring and validation before a full commitment to the new environment. In summary, the switch between the blue and the green environments in a blue-green deployment is achieved by controlling the traffic routing via load balancers, DNS, or reverse proxies with continuous health checks and monitoring, ensuring a safe and seamless transition. The next question is, what are the tools and technologies that you can use to implement blue-green deployment in the cloud? The answer to this is, in a cloud environment, implementing a blue-green deployment strategy involves leveraging several cloud-native tools and technologies to ensure smooth and efficient deployment with minimal downtime and maximum availability. Here's a comprehensive list of the tools and technologies that can be used. The first one is load balancers and traffic routing. The cornerstone of a blue-green deployment is the ability to switch traffic between the two environments, blue and green. Several cloud providers offer robust load balancing and traffic routing capabilities. First is AWS Elastic Load Balancer or ELB. You can use Application Load Balancer ALB or Network Load Balancer NLB in AWS. Both allow you to easily switch the traffic between blue and green environments by modifying target groups, making it seamless to route the traffic between instances or containers. Second is Google Cloud Load Balancer. Similar to AWS, GCP provides a global load balancer that can handle traffic contribution across multiple backend services, enabling smooth traffic switching between blue and green environments. Third is Azure Load Balancer or Azure Traffic Manager. In Azure, we can use the Azure Load Balancer or Traffic Manager to manage the routing of traffic between blue and green environments. The Traffic Manager allows for more sophisticated routing, including failover and geo-based distribution. The next is NGINX or HAProxy. For self-managed environments or more customized traffic routing, using a reverse proxy like NGINX or HAProxy can be an efficient solution. These tools can be configured to switch traffic based on environment status or to handle the canary deployments. The second one is container orchestration for containerized deployments. If your application is containerized, container orchestration platforms help in managing the deployments and traffic routing. First is Kubernetes. Kubernetes offers ingress controllers that allow fine-grained control over traffic routing between services. You can leverage Kubernetes' rolling update strategy, but for blue-green deployments, you can use services or ingress objects to control which version, blue or green, of your application gets the traffic. Kubernetes service and namespace can also be used to isolate environments. The second is Amazon ECS or EKS. On AWS, if you are using ECS, that is Elastic Container Service, or EKS, which is Elastic Kubernetes Service, you can define target groups for blue and green in containers in ECS or switch between two sets of Kubernetes deployments in EKS to implement blue-green deployment. The next is Google Kubernetes Engine or GKE. GKE simplifies the orchestration of Kubernetes workloads and allows you to easily implement blue-green deployments using multiple deployment strategies and ingress controllers. Third is infrastructure as a code tools. Infrastructure as code tools allow you to automate the setup and tear down of your blue and green environments, ensuring repeatability and consistency. The first is Terraform. Terraform is an open source IEC tool that works seamlessly with cloud providers like AWS, Azure, and GCP. You can use Terraform to define your infrastructure, including load balancers, servers, and networking resources. With Terraform, you can automate the creation of blue and green environments and easily switch traffic between them by modifying load balancer configurations or DNS settings. The next is CloudFormation AWS. If you are working in AWS, CloudFormation allows you to define and manage your infrastructure as code. You can create blue and green stacks with CloudFormation templates and manage the switch between them via updates or new stack launches. The next is Azure Resource Manager or ARM. For Azure, you can use ARM templates to automate the deployment of blue and green environments and manage the infrastructure. Fourth one is CI/CD tools. Continuous integration, continuous deployment tools automate the release pipeline and the management environments. First is Jenkins. Jenkins can be configured to automate the deployment process, ensuring that new code is deployed to the green environment, tested, and then promoted to production by switching the traffic. The next one is GitLab CI/CD. GitLab's integrated CI/CD pipelines allow for easy management of blue-green deployments, including automated tests, artifact creation, and deployment strategies. The next is Circle CI. Circle CI enables automated deployment and rollback strategies, and it can be configured to handle blue-green deployments by adjusting routing through load balancers. The next is Argo CD or Flux. For Kubernetes, tools like Argo CD and Flux automate GitOps style deployments, which can help manage the blue, green, and canary deployment strategies by syncing configurations and monitoring the health of deployments. The fifth one is DNS management and traffic routing. DNS management tools are important for managing the traffic routing between the two environments, especially when you are implementing blue-green with a global or regional DNS solution. First is Route 53 AWS. Route 53 AWS can be used to control traffic routing between blue and green environments using weighted routing policies. You can gradually shift traffic from blue to green and perform a full cutover once the green environment is validated. The next is Cloudflare. Cloudflare can be used to manage DNS routing and traffic load balancing between blue and green environments. Their load balancing feature helps manage traffic distribution globally and can be adjusted in real time. The next is Azure DNS. Azure DNS can be used to manage DNS records and route traffic to either the blue or green environment. With Azure Traffic Manager, you can implement geo-based or weighted routing policies for the traffic switch. Sixth one is monitoring, logging, and health checks. Continuous monitoring and logging are essential to ensure that the blue-green environment performs as expected before a full cutover. For this, first is Prometheus and Grafana. These open source tools can be integrated with your cloud services to monitor the health and performance of both the blue and the green environments. You can set up alerting or to monitor metrics like error rates, latency, and resource usage. The next is CloudWatch, AWS. So AWS CloudWatch allows you to monitor resources in real time, set alarms, and automatically take action, for example, rollback based on predefined metrics. The next is Datadog, a powerful monitoring tool that can provide insights into both the blue and the green environments. Datadog also offers real-time alerting to ensure that performance degradation or issues are detected before full traffic is switched. The next is Elasticsearch, Fluented, Kibana, EFK Stack. Logging and monitoring the deployment status and health of blue and green environments are crucial. The EFK stack can provide powerful log aggregation and analysis to track deployment performance. The seventh one is cloud native deployment platforms. So AWS Code Deploy, this is the first one. AWS Code Deploy is a fully managed deployment service that automates application deployments to instances, containers, or Lambda functions. It has built-in support for blue and green deployments and can easily be integrated with AWS services like ELB or Route 53 for seamless traffic management. The next is Google Cloud Deploy. Google Cloud's managed deployment service allows for blue-green deployment strategies, automating the routing of traffic between environments in GKE or Compute Engine. Then third one is Azure DevOps. Azure DevOps pipelines can be configured for blue-green deployments with tasks to manage the traffic switch and perform automated validation. Conclusion: to implement blue-green deployment in a cloud environment, a combination of traffic management tools like load balancers, DNS, and container orchestration platforms like Kubernetes, ECS, EKS, infrastructure as code tools like Terraform or CloudFormation, CI/CD pipelines like Jenkins or GitLab, and monitoring or alerting systems like Prometheus, CloudWatch, or Datadog are crucial. By automating the process and ensuring traffic control, automated rollback, and monitoring, you can achieve a reliable zero downtime deployment strategy, increasing agility and reducing the risk of errors during production releases. The next question is, can blue-green deployment be used with containerized applications? The answer to this is yes. Blue-green deployment is not only compatible with containerized applications, but it can also be highly beneficial in such environments. Containers offer the flexibility and portability necessary to seamlessly implement blue-green deployments, ensuring high availability and minimal downtime during application releases. Now let's discuss how blue-green deployment works with containerized applications. So in a containerized environment, blue-green deployment can be applied by managing two identical set of containers, one representing the current production version, that is blue, and the other representing the new version, which is green. Containers offer key benefits such as fast provisioning, scalability, and isolation, making it an ideal strategy for deploying new versions without impacting the end user experience. Now the key steps to implement blue-green deployment with containers are container orchestration. Container orchestration platforms like Kubernetes, Amazon ECS, or Google Kubernetes Engine are commonly used to manage and automate containerized applications. They provide the necessary tools to control traffic, scaling, and health monitoring, which are crucial for a smooth blue-green deployment. The first is Kubernetes. In Kubernetes, you can leverage deployments to manage blue and green environments. You can define two separate deployment configurations, one is blue and one is green, and use a service to control traffic routing. With Kubernetes, traffic can be directed between blue and green using labels, ingress controllers, or service updates, allowing for an easy switch. Second is Amazon ECS or EKS. In ECS or EKS, you can define two separate ECS services or Kubernetes deployments for the blue and green environments by updating the load balancer configuration to point to the green environment after validation. You can manage the traffic between the two sets of containers. For seamless traffic switching, the key advantage of containers in blue-green deployment is their lightweight nature and the ability to quick spin up or down entire environments. Once the green environment, the new version, is up and running, load balancers or reverse proxies can be configured to switch the traffic from blue, that is the old version, to green, that is the new version. The first is Kubernetes ingress. In Kubernetes, you can define multiple versions of an application as separate deployments. A simple change in the ingress configuration can route traffic to the green, making the switch seamless. The second is load balancers. In ECS or EKS, load balancers such as AWS ALB, that is Application Load Balancer, can manage routing traffic between blue and green containerized services by simply updating the target group associated with the load balancer. You can switch the traffic between the environments. For health checks and rollbacks, one of the core benefits of using blue and green deployment with containers is the ability to perform real-time health checks. Containers, being isolated and reproducible, can be continuously monitored for performance and availability. If the green environment fails health checks, the system can automatically roll back to the blue environment using minimal risk during a deployment. First is Kubernetes health checks. Kubernetes supports liveness and readiness probes that can automatically check the health of containers. If the green container fails, traffic can be redirected back to blue without any user impact. The second is Amazon ECS task health checks. ECS supports health checks for containers, and load balancers can automatically reroute traffic to the blue environment in case the green environment is unhealthy. For scalability and resource efficiency, containers are inherently scalable and can be rapidly replicated, making it easier to manage load distribution during the transition. During a blue-green deployment, container orchestration platforms allow for efficient scaling of both the blue and green environments based on traffic demands, ensuring no performance degradation during the switch. Automation via CI/CD pipelines. The containerization ecosystem is often coupled with CI/CD pipelines that automate the deployment and switching process. For example, Jenkins, GitLab CI/CD, or Argo CD can automatically handle the process of pushing new container images to the green environment and then updating the routing mechanism to switch traffic. CI/CD integration. For CI/CD integration, once the green environment is validated via automated tests or manual verification, the pipeline can automatically update the service definition to route traffic to the green containers, completing the blue-green deployment seamlessly. For tools and technologies that facilitate blue-green deployments with containers, the first is Kubernetes with Helm, ingress controllers, deployments, and services. Second is Amazon ECS or EKS with ALB, ECS services, and task definitions. Third is Google Kubernetes Engine, GKE. The next is Docker Swarm for simpler container orchestration. Next is Istio or Linkerd, service mesh technologies that help manage traffic routing in microservices architectures. The next is Terraform for infrastructure as code. The next is CI/CD tools like Jenkins, GitLab CI, Argo CD, or Circle CI. The key benefits are minimal downtime, safe rollbacks, efficient resource usage, and consistency and reproducibility. Now, in conclusion, blue-green deployment works exceptionally well with containerized applications due to the inherent benefits of containerization, such as rapid provisioning, scalability, isolation, and portability. By leveraging orchestration tools like Kubernetes, ECS, and Circle CI and CI/CD pipelines, teams can ensure smooth, automated, and risk-free deployments, minimizing downtime while maintaining a high availability for end users. Containerized applications enhance the efficiency, reliability, and flexibility of blue and green deployments, making it a perfect fit for modern and cloud-native environments. The next question is, how would you handle database changes during a blue-green deployment? The answer to this question is handling database changes during a blue-green deployment requires careful planning to avoid downtime, data loss, and inconsistencies. Here is how you would approach it. The first is backward compatible schema changes. Apply non-disruptive schema changes, for example, adding columns and new tables that don't break the blue environment. The next is use tools like Liquibase or Flyway to automate and version control schema changes. Second point is dual writes and replication. Implement dual writes to ensure both the blue and green environments receive data updates during the transition. Use data replication, for example, change data capture to keep both the environments in sync. Third point would be versioned migrations. Use versioned migrations to incrementally apply the changes in stages, ensuring backward compatibility. Use feature flags to toggle between the old and the new database features. Fourth point would be data synchronization. Migrate data gradually, especially for large datasets, using tools like Flyway or Liquibase. Split data migrations into manageable phases to reduce risk. Fifth point would be safe rollback. Take database backups or snapshots before applying changes. Use atomic migrations and revert changes if something goes wrong. The sixth point is testing. Thoroughly test database changes in a staging environment that mirrors production before applying to blue and green. Seventh point is monitoring. Continuously monitor database health using tools like Datadog or Prometheus to ensure smooth operation after the switch. By using these strategies, I can ensure zero downtime and data consistency during blue-green deployments with the ability to roll back safely if needed. The next question is, how do you manage configuration settings in the blue-green deployment? The answer to this is managing configuration settings during a blue-green deployment is critical for ensuring consistency and smooth transitions. Here is how I would approach it. The first is environment-specific configuration. Use environment variables or configuration management tools like Console, Vault, or Spring Cloud Config to store environment-specific settings for blue and green environments. Ensure the configuration is externalized so it can be easily updated without modifying the application code. The second is version control for configurations. Store configuration files in version control systems, for example Git, alongside the application code to track the changes and roll back if necessary. Third is automated configuration updates. Implement CI/CD pipelines to automatically switch the configurations based on the target environment, either blue or green, during deployments. Use feature flags to toggle configuration settings dynamically between blue and green environments without any downtime. Fourth is seamless switching. Use tools like Kubernetes config maps or AWS parameter store to manage and update configurations on the fly, ensuring a smooth switch between environments. By externalizing and automatic configuration management, I can ensure that blue and green environments remain consistent and changes can be rolled out safely and efficiently. The next question is, how do you ensure that the blue and green environments have the same data state? The answer to this is, to ensure the blue and green environments have the same data state, I would implement the following strategies. First is database replication. Use real-time database replication, for example MySQL replication, PostgreSQL streaming replication, to keep data synchronized between blue and green environments. The next step would be data migration scripts. For schema changes, apply backward compatible database migrations in stages, ensuring both environments can access the same data state during the transition. Third would be dual writes. Implement dual writes to both blue and green databases during the deployment to ensure data consistency while switching the traffic. Fourth point would be data verification. Use health checks and data validation scripts to verify that both environments are in sync before routing production traffic to green. By using replication, dual writes, and automated migration scripts, I can ensure data consistency and prevent discrepancies between the two environments during the deployment. The next question is, can you implement blue-green deployment without a load balancer? How would that work? You can answer to this as, yes, blue-green deployment can be implemented without a load balancer, though it requires alternative traffic management strategies. Here is how it would work. First is DNS switching. Use DNS-based routing to direct the traffic between the blue and the green environments. You can update the DNS records, for example, using TTL-based switching to point to the green environments after deployment. This approach is simple but has the downside of DNS caching delays. The second point would be application level routing. If the application supports it, you can implement version-based routing directly within the application, where it checks the environment version and routes traffic accordingly. Third point would be server or instance switching. If using container orchestration like Kubernetes, you can manually switch the traffic by scaling down the blue environment and scaling up the green environment, updating the environment references in the service configuration. Fourth would be proxy or reverse proxy. Implement a reverse proxy, for example, nginx, to manually route traffic based on application logic or headers, simulating load balancer behavior. While these methods can work, a load balancer offers more flexible and automated traffic management, making it the preferred approach in most cases. However, these alternatives are viable when load balancing is not available. The next question is, what happens if you deploy to the green environment and a bug is found before switching traffic? You can answer to this question as, if a bug is found in the green environment before switching traffic, I would do the following things. First is roll back to blue. Immediately keep traffic directed to the blue environment, ensuring no impact on users. Second would be fix the bug. Quickly address the issue in the green environment without affecting production. Third would be retest. After fixing the bug, thoroughly test the green environment to verify that the issue is resolved. Fourth would be redeploy green. Once validated, reattempt the deployment by switching traffic to green. This approach ensures minimal disruption and allows quick recovery without affecting the end users. The next question is, how would you perform database migration during the blue-green deployment without causing any issue? The answer to this is, to perform database migration during a blue-green deployment without causing issues, I would do the following. Use backward compatible changes. Make schema changes that are non-disruptive, like adding new columns or tables, ensuring the blue environment continues to function while green uses the new schema. Next would be data migration in phases. Implement incremental data migration in small, manageable steps, applying changes gradually to avoid the disruption. Next would be dual writes. During the transition, write to both blue and green databases to ensure data consistency between the environments. Then the next point would be automated rollback. Take regular backups and use transactional migrations to allow easy rollback in case of issues. Next is verify with testing. Validate migrations in staging and run health checks to ensure both environments are in sync before switching traffic. This approach minimizes downtime and ensures data integrity during the migration process. The last question is, what are the advantages of blue-green deployment over traditional deployment methods? The answer to this is, blue-green deployment offers several key advantages over traditional deployment methods. First is zero downtime. Second is easy rollback. Third is improved testing. Fourth is risk mitigation. Fifth is scalability. These advantages make blue-green deployment ideal for high availability systems and continuous delivery pipelines. Thanks for watching this video. I hope it would help. Please like and share my videos and subscribe to my channel.